the next video in our geometric sequence. So today we're going to start talking about area. This is section 10.6 on your online textbook. What is area? Area refers to a region measured in square units. Area is the amount of space covered by a shape or region. If we were to take a triangle, for example, we know that the perimeter is the sum of the three sides of the triangle. But if we want to look at area instead, we're going to look at the inside of the structure. In other words, how much space is the triangle covering on the slide itself. To make things consistent, we tend to measure things into square units. If we were to say take a rectangle and say that we have 5 and 4, then what I could do is break up the structure so that if we have 5 units along the top, 1, 2, 3, 4, 5, and 4 units on the side, 1, 2, 3, 4, then the number of cubes or number of squares inside the structure would be its area. We would say that the area of this rectangle, for example, would be 20 square units because I don't have the units labeled. Here are 4 of the simple formulas. Please note that there are multiple formulas for different structures. However, these are your basic ones. You can either derive the others from these 4, or you can combine them together to get them. So again, we have a triangle. Area of a triangle is 1/2 base times height. B stands for the base of the triangle. H is the height. Base and height is also seen as the dimensions of a triangle. Area of a square is going to be S squared. S is the length of the square. We have a rectangle. Area equals length times width, where L is the length and W is the width. Length and width are also dimensions. In class, we also talked about how we could use the variables A and B, but again, as long as one variable represents one side of the rectangle and the other variable represents the other side of the rectangle, we can still use the same relationship, the A equals length times width. And then circle. The area of the circle is going to be pi r squared. As we talked about in class, the only thing that a circle can be measured by is its radius. So the calculations of perimeter, area, and eventually volume and surface area are based on the radius. So let's do some examples. Let's find the area of a square that has a side length of 13 inches. Let's go ahead and draw it first. So we have a square and 13 inches. Based on our formula, the area of the structure is going to be S squared, which in this case would be 13 squared. That means the area of the structure is going to be 169 inches squared. Now remember, this is volume, so it is not volume, this is area. Oh my goodness, it is late. So, since this is an area, we need to make sure that our label has the squared in it. That way it indicates we're talking about area. When we talked about perimeter, it was a linear measurement, so it was just whatever the label already was, but in this case it is going to be the label squared. Okay? But that's the area. That's the area of the square. Nothing else to it. Now if we were to use the area of the rectangle to find the square area, we would still just multiply 13 by 13 because it's still length times width. Let's do the next one. Let's find the area of a triangle with a height of 5 centimeters and a base of 12 centimeters. We can draw the circle in many different ways. But you could have the triangle go like this, 5 centimeters, with a base of 12. So 5 cm, 12 cm. You could even draw this, and this be 5 centimeters, and this be 12 centimeters. The important thing about a triangle is that the height of the triangle is in relation to the base. If I were to flip the triangles on their heads, I would still have 5 centimeters towards the 12 centimeter base. That's still considered height and base, even if I were to flip it upside down. But using the formula, we have the area of the triangle is equal to 1/2 the base times the height. So in this case, we have 1/2 of 5 times 12. Now what is nice is that since multiplication is commutative, I can multiply in any order I want. So instead of doing 1/2 times 5 to get another fraction, I can instead multiply the half to the 12. So A would then equal 6 times 5, which is 30, and then we have centimeters squared. So the area of the triangle would be 30 centimeters squared. That's it. Remember that in the last video we talked about compound figures. Compound figures are figures that are a mismatch of 2 or more shapes. So we can still find the area of this in the same way as we would find the perimeter. Well, we use a perimeter, we use a definition. Here we're going to break it up into our common shapes. So here's our figure. I'm going to go ahead and draw a line from here to here. What this does is it breaks up the two structures. We actually have a rectangle on top of a parallelogram. Now the area of a parallelogram is similar to the area of a rectangle, where it's still the 2 dimensions. But in this case, the dimensions to the parallelogram is going to be its height to its base. So in order to find the area of the compound figure, we need to know the area of the rectangle, and then we'll add that to the area of the parallelogram. So the area of the rectangle is equal to length times width. And we also know the area of the parallelogram is actually base times height. But notice how it's still 2 dimensions. It's just the relationship. It's just how each value is measured that determines whether it's a length width or base height. But it's still the same type of measurements. So if I want to find the area of the circle, I need to take not the area of the circle, area of the compound figure, we need to take the length times width, and then we're going to add that to the base times height one. So this area is going to be, so for the rectangle, we have 16 by 7. And then for the, it's too blue. For the parallelogram, we're going to have 7, and then this time 10 for my base, or for my height. No, base. 7's my height, and it's my base. 10 times 7. So my area then is going to be 16 times 7, which is 112, plus 70, which ends up being 182. It is in centimeters squared, or squared centimeters. So even though we have a compound figure, we're still finding area in the same fashion. We're using the formulas and combining them together depending on the shapes that we have. Please note that we also could have taken instead a line here and broke it up into 3 different rectangles, or two rectangles and a parallelogram. We can always break up the shapes into smaller shapes and use those simple formulas to find the area. Let's do another one. Find the area of the figure. Once again, we have something that is actually considered a compound figure. If we are to take a line here, starting from this vertice and go all the way across, we actually have two structures. We have a rectangle and we have a triangle. So if we find the area of the figure, it is the same thing as finding the area of the rectangle and the area of the triangle. In other words, the area of the figure is equal to the area of the rectangle plus the area of the triangle. The area of the rectangle is 15 times 7, because it's length times width. Now here we have to figure out the base and the height of the triangle. We know the base is 17. We're going to let the height right here be a number. But what number is it? That's the question. Well, we know from the property of a rectangle that the top half is 7. So the question is, what is this side length? Well, if the whole thing is 15, then the missing piece that we need is 15 minus 7, which is 8. That gives us a height of 8 meters. So we have 15 times 8 times 1/2. Remember, since it's a triangle, we have to make sure it has half of the area. There we go. All right, so that means the area is going to be 15 times 7, which is 105, plus 15 times 4, because half of 8 is 4, is 60. So the area of this compound figure is equal to 165 meters squared. There we go. Again, all we did was we broke up the structure into shapes I already knew. Here's a question for the class. How would you find the pink region? Now, it might not be very easy to see here, so I will highlight it more. The region I'm looking at, do purple, is the area all in here. If I wanted to figure out what all this was, how would we do it? That's a question we're going to ask and explore in class. See you then.